Hello, everyone. Welcome to the KDD 2021 award ceremony. Next slide, please. So today we're going to present several important awards for SIGKDD. SIGKDD has a history of more than 20 years. Over the years, the SIGKDD Executive Committee has instrumented several important awards, including the Innovation Award, which celebrates one individual's technical contribution, and the KDD Service Award, which acknowledge individuals' service contribution. We recently also started the Rising Star Awards, which actually acknowledge the achievement in the earlier career. So we also have the Pass of Time Award, which actually recognize a paper or papers published more than 10 years ago that have already generated significant impact to the field and beyond. And next slide, please. The first award I'm going to present today is the SIGKDD Innovation Award. And this year, this award goes to Dr. Johannes Gerke from Microsoft Corporation for his outstanding contributions to new data mining algorithms and data privacy. Next, I'm going to hand over the stage to Johannes for his speech.
Okay, hi, so I'm Johannes Gerke from Microsoft. And I wanted to start by thanking the awards committee, the nominators, my collaborators, and the awesome SIGKDD community for this research. I want to go a little bit into my collaborators. I mean, first of all, there's my PhD advisor, Raghu Ramakrishnan. He was really an amazing advisor who taught me, especially what is quality research. And then, of course, the tools of the trade, right? How to run experiments, how to design and build systems, how to write good papers, how to advise students. And then later here at Microsoft, also, of course, how to thrive in industry. I also want to thank my amazing group and collaborators at Cornell. There was just a really amazing set of faculty with interest in the KDD space. I was really blessed with 25 amazing PhD students, and then postdocs, research associates, and also developers, and many immense students and undergrads who contributed to our research, without whom it would have never happened. And then also really thank you to all my collaborators over the time. You could see when that list is so long that you're really getting old. So what I want to talk today is I want to talk about two topics. And we are lucky that we work in an area where there are so many exciting open topics and so many really 10-year challenge problems. But I thought I'll talk about two topics that are a little bit close to my heart here, that are maybe a little bit more near term, specifically two topics that match with the themes of the award that I was recognized for, namely new data mining algorithms and data privacy. So let's dive into these two. So these days, I still work on new data science or machine learning algorithms, but I work in them in a different context, namely in Microsoft Teams. You may know Teams. It's the hub for teamwork in Office 365. It also includes audio and video conferencing. And especially what you see very often in audio and video conferencing is that you have noise at home. We all work at home right now. And here's what we could do with a good machine learning algorithm, a good deep learning algorithm.
I'm still working from my apartment, and while it can be challenging at times sharing a space with my roommate, I love the fact that I save an hour each day from my commute to the office.
Yeah, a lot of my colleagues are starting to work back in the office. I think they just find it a quieter environment. And hey, there's really good parking right now.
So I got an email from the GM last week about the new work from home policy for next year. I think when things get back to normal, I'll probably still work from home at least twice a week.
Yeah, and so I think what this just shows is that, right, I mean, the field has really advanced so much since the early days when we worked on, association rules, clustering, decision trees, and other interesting algorithms. But what it means is that the algorithms now have become different, and they've become part of larger systems that actually have real impact in people's lives. And I wanted to show you one other situation that I've worked on where this actually really drove it home for me. And this is, again, when you look at audio, video in Teams, you have basically a big resource management problem, where you have the data plane from capturing, encoding, sending, and then on the other side, receiving and decoding. And then you have, a control plane that's here in, at the bottom, where you have capture control, frame rate resolution, you have the rate controller, You have the quality control and you have bandwidth estimation, either receiver or sender side. And if you look at this before data science and machine learning was incorporated here, basically what the developers did is they did a very thoughtful A/B testing with lots of hand-tuned parameters for video resource management, audio jitter buffer control, bandwidth estimation, and so on. You can imagine that this is, of course, a very complex system. I mean, the analogy to me is a little bit like this is like the query optimizer of a database system, with this very complex control plane and this very complex set of problems. And this is a little bit fewer lines of code than a database query optimizer, about 150,000 lines of code, but still about 1,000 hand-tuned parameters. And so the journey that we're on is to replace all of these red blocks, right, with one big green block, right? Machine learned control. That's where the data science is hidden, of course. And you could imagine actually that, if you do this on a control plane, why don't you also do it in data plane and maybe just, have fewer boxes and put the magic word of machine learning in each of these boxes, right? Now, the interesting thing is that both of these are very different, right? The left side is, of course, you have lots of handwritten code, and the right-hand side, you have much less handwritten code. You have a simpler architecture with maybe fewer lines of code and your hand-tuned parameters. On the left-hand side, all the learning is done by data. On the right-hand side, everything is done. On the left-hand side, everything is done by programmers, and on the right-hand side, everything is learned from data. So this is, of course, the difference between the world of software 1.0 and software 2.0, where on the left-hand side, you program with code, and on the right-hand side, you program with code, data, and models. And we have seen many different names for some of the tooling around this, which is called sometimes ML ops. But it really means that we now have the algorithms not anymore from textbooks, but they are in models and they get better with more data. Now, the interesting question is when you want to put this in production, right, this is very different than actually just implementing a new algorithm. Especially if you look at the difference between software 1.0 without models as compared to software 2.0 which is with models, you have a very different process now. You release, define, task design modules, write, reuse code, and debug on the left-hand side. Whereas on the right-hand side, you actually work with data. You collect data and labels, you prepare the data, train the model, and so on. But actually, this is sort of the way that a grad student would think about it. But actually, in practice, in large systems, right, if you think about teams where we have hundreds of developers working together to build very complex cloud-based systems that scale across the world, that have redundancy and reliability and lots of different features, you have the inner cycle where the developer works with herself, in debugging, editing code, and building. But then you have a more complex outer cycle where you have, code review, testing, a CI/CD pipeline, you have release management, you have monitoring, then you have issue management, you have, documentation that's of course being done, then you have analytics over all of this. And so this is a much more complex process that, really in some sense for the first time, really brought it home for me that, this is not computer science, but software engineering. And what this means is really that we have taken large-scale software development, we have made an engineering discipline, and this engineering discipline allowed us to collaborate with very, very large number of people together. And so if I now compare this, what's happening here, that for software 1.0, we actually have developed engineering tooling. We have tooling for repeatability, for testing, for modules decomposition, for debugging, abstractions. We have tools for the performance tuning, and we have tools, for DevOps. And in the software 2.0 world, this is a wide open space, which I think this community here is also really prime to address. So one big challenge comes in how do we write, debug, release software with models? And, I just want to give you one example here in abstractions, right? We know how to hide complexity from the developer. And we're actually, even now, if you think about tools like Power Apps or so, we're building low code or no code tools that allow everybody to be a developer. On the right-hand side, right, for software 2.0, we really don't have great tools yet that allow us to hide a lot of the complexity from the developer. Maybe the best tool that we have or the best abstraction that we have is now pre-trained models and models as a platform, right, where you can go into Azure and, you have GPT-3 available as a platform. And then you can build, your application on top of it. Similarly for debugging, for testing, and for DevOps, right? We're missing tooling on the right-hand side in the software 2.0 world that we have on the left-hand side. So again, I would pose it to this community as one of the open challenges is how do we write, debug, and release software with models? Let me go to the second problem, right? One of the other things that I worked on was data privacy. And it was actually a really fascinating set of problems at the beginning about what is the right privacy definition with a bunch of false directions. And then, after having settled on differential privacy, how do we actually make this work on real data, which then resulted in, on the map, where you released the very first data set that, by any government agency that had ever been published, to the public, which then, of course, luckily, many of my students and other collaborators in the community pushed forward, really with the culmination now that the 2020 census is being published with differential privacy, which I think is a great, bravo to the whole community of people who have been pushing the science forward. On the data privacy side, there is another big challenge that I see in practice here in industry, which is this notion that when I have code, I can look at this code and we can all look at this code together here and see and find the error, right? And if you sort of squint really hard, you can see that cur_min is not initialized, right? And that actually is a bug in this code, right? And we, by the way, have now a bunch of testing tools, right? Unit test frameworks, test automation, fuzzing, and so on, that allow us to avoid these bugs. The question again is, in the software 2.0 world, where we don't have such good tooling, we don't know really what to do. And then in addition, if you're actually away from the model and the code, right? If you have to test, debug, and explain eyes off, which is what we have to do in the case of enterprise data, where the developer cannot look at the data, where the scientist cannot look at the data, right? How do we actually test, debug, and explain models in this case? How do we deal with data attacks? And in general, how to debug these kind of models? And this, of course, is really hard because even from a science point of view, right, robustness is still in its early days, right? Where you can take a pig, you add a little bit of random noise, and then actually it may come out to be an airliner. And the second big problem here is not only that you're sort of one hop away from the data, and therefore you cannot look at the data, and you don't get access to the data. I mean, this is actually one of the things after I joined Microsoft I was most impressed by, right? How careful Microsoft actually is with the privacy of its customer data, of which I've never seen a single bit. And the other problem is that data in the enterprise is not like data on the web, where all of us are querying the same set of resources and the same set of pages. But actually data in the enterprise, if I look at a data set and then Wei looks at a data set and Jan looks at a data set, we all may see different instances of this data set because we all might have different access permissions on which documents or which content we actually may access. What this means is that as compared to the web, again, where every user sees the same content, in the enterprise, every user sees a different subset of documents or content. What this means is that even for simple cases like retrieval, where you very often augment documents with this link structure, the related content is very different for every user, and even the set of content that every user can access is very different. So how do we do model building, ranking, retrieval, recommendation in this set where I don't want only a personalized model, but actually even the content over which the model can be built for me is very different than for everybody else. So again, I wanted to thank the community for this award. I talked very briefly about two interesting open problems. One of them is in the space of software 2.0 and what is the tooling, science, processes that we need to really make us as developers and as users of these models really successful. And the second one is then the whole issue of data privacy, where in the enterprise, we're an arm's length away, where we never see the data actually of our customers. And how do we search and rank and model building over data with access control? Thank you very much.
Thank you, Johannes. And this is very eye-opening, wonderful talk. Congratulations to this award. I think it's a big achievement.
Thank you.
The second award I'm going to present is the SIGKDD Service Award. This year, the award goes to Dr. Shiping Yu from LinkedIn for his outstanding history of service to the KDD community. And the Shiping has been actually serving as the sponsorship chair for KDD for years. So he has been heavily involved in the organization of the KDD conference year after year for quite a few years. So this year, we wanted to take the opportunity to recognize his contribution and to thank that, his wonderful service to the KDD community. And we hope that we can continue to enjoy his service in the future. So Shiping has recorded a word speech.
Hello, KDD. My name is Shipeng Yu, and I'm speaking to you from Sunnyvale in California. I'm truly honored to receive the SIGKDD 2021 Service Award. For those of you who don't know me, I grew up in China, did my PhD in University of Munich in Germany, and I've worked in data mining and machine learning industries for more than 15 years. Currently, I am a director of AI engineering at LinkedIn, leading a team of awesome AI engineers on growth, communications, and other exciting areas. My journey with KDD started 20 years ago, and I have been contributing to the KDD and the general AI community as an author, speaker, reviewer, senior program committee member, and organizer over the years. KDD is one of my favorite communities as it strikes the right balance between innovative and cutting-edge research and practical, scalable, and reproducible solutions and applications. I had the opportunity to serve as the Associate General Chair for KDD 2016 in San Francisco, supporting General Chairs Balaji and Mohak. This was widely regarded as one of the most successful KDD conferences till date, and had attracted more than 2,700 attendees from 88 countries. The year after, I took on the role of General Co-Chair for KDD 2017 in Halifax, Canada, and welcomed more than 1,700 attendees, despite the relatively remote location. This made it one of the best KDD conferences in non-metropolitan cities. I would like to thank all the chairs, volunteers, and staff to make this KDD conference successful, and many of them continue to serve the community even today. Since 2018, I transitioned off my general chair duties and have been focusing on the sponsorship effort for KDD till today. This is a crucial part of the KDD conferences. The goal of sponsorship is not to attract sponsorship dollars and maintain a positive balance sheet of the conferences. It is to serve as a bridge to connect attendees, sponsors, and the community, and to create economic opportunities for talents in this critical workforce in the KDD community. To better serve this role, I talked to Jen and took on a new role and became the first SIGKDD sponsorship director, working closely with Jen, Mike, and the SIGKDD executive committee to drive sponsors' engagement. With a strong sponsorship team, we were able to raise more than $1 million for KDD 2018 and 2019. Both are record high amounts in KDD history. And it drove a great amount of value to both attendees and the sponsors. Since COVID started in 2020, the sponsorship efforts met with great challenges due to the virtual conference setup. But thanks to the strong sponsorship co-chairs, we were able to quickly adapt to a virtual platform for sponsors and continue to drive connections and values. So I would like to encourage you to go to the virtual platform at KDD 2021 and to enjoy the conference benefits. I would like to thank Jen, Mike, and the EC, all my co-chairs Balaji, Mohak, Stan, and Faisal over the years, my sponsorship team Ritwik, Lei, Faisal, Hongsha, and Brittany, and all the colleagues and friends who have helped me, guided me, supported me, and challenged me over my service years at KDD. Without your support, I could not have grown to who I am today. Last but certainly not the least, I would like to thank my family for always being there and supporting me. I also encourage everyone who is watching this video to serve the KDD community, whether you are still a student or a well-established researcher or AI practitioner. The Bible says it is more blessed to give than to receive. Communities ultimately are for us to learn, to interact, to serve, and to grow. KDD has been that community for me. Hope we can all grow together at KDD. Thank you all, and have a great conference.
Thank you, Shiping. Congratulations for the Service Award. Next is the SIGKDD Rising Star Award. This is a relatively new award that we started just a few years ago. This year, the award goes to Dr. Ben Hu from Rice University for his significant research in human-centric data mining and the contribution to developing interpretable and automated methods to make complex machine learning algorithms easily used by domain experts. Okay, so are you ready?
Yes, thanks Wei for the nice introduction, as well as KDD for the prestigious award. So I would like to firstly give you a brief introduction about my ongoing research on human-centric machine learning, just in case. So basically, my research is to answer the following two questions showing on the slide. And we have been working on these two almost the opposite direction of human-centric machine learning systems and algorithms, aiming to enable end users better utilize powerful yet complicated machine learning tools. So as you can see from the slide, on one hand, we aim at opening the black box of complicated machine learning models. It's called interpretable machine learning, which is to answer the question, so why and how a decision is made through some algorithms and systems. So this has been a more and more important direction recent years in many aspects. For example, in healthcare, it would be very helpful to build up trust of AI systems by providing proper interpretations of certain diagnoses to end users. These end users could be patients, medical doctors, or even the insurance companies. Another example is autonomous driving. As we know, there were some bad accidents happened before, and after the accidents, it would be very helpful to understand the reasons of AI decisions at that certain moment, such that it is possible for data scientists and engineers to debug and upgrade the system towards a better way. So on the other hand, we aim at constructing an effective black box by developing automated machine learning systems, which could enable the end users with limited data science background to easily make use of complicated machine learning algorithms by simply feeding the data, such that our algorithm will be able to output the recommended model associated with hyperparameters and the trained parameters. And the domain experts can easily adopt the outputted model in their downstream applications. So the end goal of this project is to democratize machine learning to be used by everyone. And happily, I would like to share our developed system called AutoKeras has been one of the mostly used open source systems on GitHub, and it has been widely used by industry and academia. I would like to take this great opportunity to thank all of my mentors, especially my PhD advisor, Dr. Huan Liu, for their guidance and patience over the years, and as well as my collaborators for their tremendous help and support to our projects and research, as well as my talented students who really made all of this happen. I always consider SIGKDD as one of my favorite communities, and moving forward, I very much look forward to continue to engage and contribute to this community. And thank you very much.
Thank you, Ben. It's wonderful. Congratulations. Okay, the Dissertation Award Committee this year has received more than a dozen nominations. And then after careful evaluation, this year, the Dissertation Award goes to Dr. Aditya Grover from Stanford University. So I believe he received his PhD last year from Stanford University. His dissertation is on learning to represent and reason under limited supervision. Congratulations, Aditya. So it's quite an honor. I'm also happy to learn that actually Aditya is going to join UCLA as a faculty in a few months. Next slide. The committee also determined that Dr. Shweta Jain received the dissertation award, the runner-up award. She graduated from University of California, Santa Cruz. Her dissertation title is Counting Clicks in Real-World Graphs. Congratulations, Shweta. Great work. Next slide. The committee also identified one recipient with honorable mention. This year it goes to Leonardo Pellegrina from University of Padova in Italy. His dissertation title is on rigorous and efficient algorithms for significant and approximate pattern mining. Congratulations. And I want to also have my personal congratulations to all three of you. And this is actually excellent dissertation work. It's actually a great honor that for KDD to have all of you as the young researchers in this field. Next slide. The Test of Time Award committee evaluate more than evaluated more than 10 papers from the past KDD conference, and those papers actually published more than 10 years ago in KDD. So this actual award committee is led by Dr. Johannes Gerke, who just received a technical contribution award. And this year, the Test of Time Research Paper Award goes to Chong Wang and David Blake for their paper on collaborative topic modeling for recommending scientific articles. This paper was published in KDD 2011. Congratulations. Next slide. The community also identified the Test of Time Award for the Applied Science track. This year, the award goes to Dan Tan, Ashish Agrawal, Deirdre O'Brien, and Mike Mayer for their paper on overlapping experiment infrastructure, more, better, faster experimentation. The paper was published in KDD 2010. Congratulations. Next slide. Now I'm going to hand over to Dr. Frida Zhu, who's going to present the next set of awards.
Thanks, Wei. Hi, everyone. So I'm going to present the Best Paper Awards of this year's KDD. First, let me introduce the Best Paper Award Committee. So this year, we have the honor to have these 5 prestigious researchers from our field to form the Best Paper Award Committee. First, we have our chair, Haixun Wang. Haixun representing the Applied Data Science track and is also chairing this subcommittee. We have Sanjay Chawla, who is the PC co-chair for research track, representing the research track. And then we have Ben Jing from representing the general co-chair. Also, we have 2 external committees, members, Professor Zhao Wei Han from University of Illinois at Urbana-Champaign and Professor Wei Wang from UCLA. And these 5 researchers have carefully studied and discussed and debated over the candidates of the paper. And finally, these are the winners. Next slide, please. First, we're announcing the Best Paper Award of Research Track. And this year, the award goes to fast and memory efficient Tucker decomposition for answering diverse time range queries. The authors are Jungi John from Seoul National University and Yu Kang from Seoul National University. Congratulations to these two authors. Next slide, please. Our Best Paper Award for the research track for student category this year goes to Spectral Clustering of Attributed Multi-Relational Graphs. And the authors are Yuli Sankash, Yuka Vlash, Saha Sohail, Claudia Plum. I hope I read all the names correct. Congratulations to all these authors. Next slide, please. Our Best Paper Award in the Applied Data Science category this year goes to Supporting COVID-19 Policy Response with Large-Scale Mobility-Based Modeling. This is a long author list. Let me read them out. Congratulations goes to Serena Chan, Mandy Wilson, Brian Lewis, Zakaria Mahab, Amber Pearson, Peng Wei Ko, Janling Gerardine, Beth Bird, David Gruski, Madha Marath, and Yuri Leskovic. Congratulations to all these authors. And we know that COVID has been a very hot topic and growing topic, attracting a lot of attention. And this is a very interesting work with a lot of interesting studies. Next slide, please. And finally, our Best Paper Award in the Applied Data Science category, runner-up, goes to Energy Efficient 3D Vehicular Crowdsourcing for Disaster Response by Distributed Deep Reinforcement Learning. And the authors are Hao Wang, Chi Liu, Ziping Dai, Jian Tang, and Guoren Wang. Congratulations to all these authors. Now, I want to remind all the attendees that we have a best paper session coming later 6 to 7 p.m. Singapore time. I believe it's 6 to 7 a.m. EDT time. And all the best paper authors will be there. Each paper will have about 10 to 15 minutes of short presentation, followed by a Q&A session and a discussion. So please join the session to congratulate our authors and interact with them. Thank you. Next slide, please. Next, I'm going to hand over back to Wei to honor our ex-KDD chair, Dr. Jian Pei. Wei,
hello.
over to you. Yeah.
Yes. Hello. So I would like to take a moment to thank Dr. Jian Pei for his outstanding service to the KDD community. As many of you may know that Jian was the KDD chair, the chair of the executive community for the past 4 years. So he retired from the chair position as of June 30th, but still remain as a member of executive committee. So over the past 4 years, actually Jian demonstrate actually exceptional leadership, especially in the face of a pandemic. So with a huge uncertainty and challenges, actually Jian lead the community to grow and overcome many unforeseeable challenges when we organize the moving the conference from in-person to online. So especially last year in San Diego. So I think, and also in addition to his extraordinary service, he's also a leader in the field in technical contribution. So if you look at his, read his homepage, right, you'll quickly recognize that actually he's been honored with many distinguished awards, including the Fellow of ACM IEEE, including the SIGKDD Research Achievement Award, including the members of Canadian Royal Academy. So there's many recognitions for Jen's great contribution to the community from the both research and the service. So in the next 4 years, actually looking forward to working together with Jen under his guidance to take the KDD community again to pass the pandemic and improve over the post-pandemic era. And so it's actually a great honor to have him as a colleague, as a friend, and advisor. So now I'm going to take the moment to hand the stage over to Jen to hear his what his thoughts, and maybe he will give us advice on how the KDD community should moving forward in the next 4 years. Jen?
Oh, thank you so much. Yeah, this is a great surprise to me because you guys just told me to attend this section, and you did not tell me that you will mention me here. So thank you so much for that. I'm very touched by that. Well, as a SIGKDD chair for the last 4 years, indeed, my major job is facilitating the discussion and brainstorming of the EC. So all the work was achieved by the whole EC. And then probably I make the discount of the capability by my misunderstanding of their ideas and back and forth doing the trials. So all the gratitude should all go to our whole EC. So thank you so much for all the people working with us in the last 4 years. And many of them will continue in this EC. That's great. And also I would like to thank many people in this community, and they really helped the SIGKDD EC to move the community forward. It happened even yesterday. I had a conversation with Dr. Wong Kim. If you still remember him, he's the founder of SIGKDD. We are chatting about the creation of SIGKDD and also what's the current channel SIGKDD. And I believe, as Professor Jeff Armand said yesterday, we just let SIGKDD grow. It will be fine. It will be going forward all the way. And I think it is the pandemic gave us a lot of challenge, but also gave us a lot of opportunities. Many things will be changed, no matter the scope of data mining will be changed, the ways that community organizations and conferences will also be changed. So this would be the right time for the switch from one generation or one kind of EC to the next one. And for the next EC, I really confident and also very hopeful for them is that they will be creative. They will break any constraints and limitations that the old school EC may have, and they will embrace the new trends and the new opportunities. I'm very confident for them, and definitely I will be here no matter what I can do for the community, for the new EC, and for the future of data mining in the next 20-30 years. Just let me know, and I'm more than happy to serve and to help. Yeah. Thank you again. I really appreciate it. Yes.
Thank you, Jan. We were very fortunate to have you as the chair in the last 4 years. You did a extraordinary job in leading KDD through the pandemic, during the big transition. So we hope to continue to have you, serve on the EC and have you make the KDD an even stronger and a bigger community in the next 4 years. Thank you very much.
Yeah, thank you, Dr. Jianpei. And if I may add a bit as the general co-chair of the KDD 2021, I think Dr. Jianpei really went out of his way to offer help and, make himself deeply involved and available for even from the very beginning stage of the planning of KDD 2021. As we all know, this year, It started as everybody hoping that we can still have offline gathering, right? And then gradually, as the situation get worse, we sort of like considering whether we want to do a hybrid mode, and eventually we decided on the virtual mode. Now, throughout the whole process, Dr. Jianpei, always is ready to offer advice and offer this as guidance. And his rich experience with all the years of KDD really helped us a lot. So I want to thank Jianpei on the behalf of all the organization committee of KDD 2021. And we really appreciate all your guidance. And we hope in the future we can work together with you further for anything that's going to work best for KDD. Thank you.
Yeah, thank you, Frida. Thank you for all the OC members of the SIGKDD 2021. Yeah, you are great.
Thanks. Yeah.
And thank you everyone for your attendance. And I think this is our last agenda for the award ceremony, and we'll have about 15 minutes to the keynote speech. And please stay tuned for the next keynote speech by Professor Claire Tomlin from UC Berkeley. It's on safe learning in robotics.